Hello everyone, welcome to a new video of GISVenture. Before we dive into our main videos, let's get comfortable with a few important terms you'll hear often. First, what is remote sensing? It's the science of collecting information about the Earth without being there physically, using satellites, drones, or aircrafts or even handheld instruments. You'll hear words like sensor, which is a camera or an instrument that captures the data. It sits on a platform like a satellite or a drone. We also use spectral bands. These are like filters for different types of light such as visible, infrared, thermal or even ultraviolet. Every image you see is made up of tiny units called pixels, which is a short form for picture element. Each pixel carries a value that represents real world data, like how green a forest is or how hot a surface might be. The values are simple numbers. An array of pixel or a grid of pixel is what we call a raster. Remote sensing images are mainly raster data. In remote sensing, the word resolution doesn't mean just sharpness. It refers to how much detail you can capture and interpret from a satellite image. There are four main types of resolution, and each tells you something different about the sensor and its capabilities. Spatial resolution. It is about the size of each pixel on the ground. A 10-meter resolution image means each pixel represents a 10 by 10 meter area. Higher spatial resolution equals finer details and lower resolution means more generalized view. Temporal resolution. Temporal resolution tells us how frequently or how often the satellite captures data over the same location. For example, Sentinel-2 revisits a place every 5 days while MODIS does it daily. Spectral resolution. It refers to the number and width of spectral bands a sensor can detect. A sensor with higher spectral resolution can pick up narrow, specific wavelengths, which is useful for detecting subtle surface features. Radiometric resolution. It tells us how finely the sensor can detect differences in brightness or reflectance. An 8-bit image can display 256 shades of grey, while a 12-bit image can show over 4000 levels. Together, these four types of resolution define what, when, and how well we observe the Earth. So next time you download satellite data, make sure you know which resolution matters most for your project. Now let's talk about GIS or Geographic Information Systems. GIS helps us organize, analyze and visualize geographic data. You can think of it like a digital layer cake. Each layer represents one kind of information like roads, rivers or rainfall. Data in GIS comes in two forms: raster, as we saw earlier, and vector, which uses points, lines and polygons to represent features. Each feature in GIS comes with details in attribute table. It's like a spreadsheet that tells us more about the data, like population, area or category. To locate these features correctly, GIS uses coordinate systems and map projections, which we generally term as CRS, that is Coordinate Reference Systems. Together, remote sensing and GIS allow us to do powerful things like measuring vegetation using NDVI, that is Normalized Difference Vegetation Index, classify land using LULC, which is for land use and land cover, and align satellite data using georeferencing. These terms are your foundation, so refer back to this glossary anytime during your learning journey. This is GISVenture and we are just getting started. Take care all. See you in the next video.